So Danica Mckellar is an actress who also is a mathematician. And one thing that you guys need to realize as we go through this year is you are all mathematicians. Anybody solving math problems, computing things, figuring out, like analyzing, like we are all mathematicians of varying skill levels. So Danica Mckellar writes these books, and the first one that she ever wrote has a very straightforward title. Math Doesn't Suck. So, what I love is she frames things in the sense of, yes, I'm a female, yes, I'm not like a genius, yes, math was a struggle for me, yes, you can do it. So, she frames things in the context of, no, math does not suck. So here's a little intro video from her that I just figured I'd show to give you guys a little introduction to who she is, and then I'm going to talk just a little bit about, we have 4 of her books in now. In the library, so if you want to check them out, I'm going to have them here, but then you can just go to the library and write on the checkout list, like if you want to use them, because I'm going to kind of try to steer people towards using this. So, without further ado, as soon as I turn on, Carolyn, would you be able to turn on the sound system over there? It's right beside that yellow Post-it note, that big old black button. Yep. Thank you very much. All right, so here is Danica Mckellar's intro. I got to turn this up, though.
Channel on My Math Universe. Okay, so I've been acting since I was 12 years old on shows like The Wonder Years, and I still act today. I've done episodes of How I Met Your Mother and The Big Bang Theory, and I'm the voice of Miss Martian on a cartoon called Young Justice. And I also write math books. Yeah, math books. Believe it or not, I used to hate math. I was terrified of it. But then I finally figured out how to make math easier and not such a big deal. And then I felt smarter, I had more confidence, I was a better student and a happier person. And that's why I started writing math books, because I want you to feel the same way. My first book is called Math Doesn't Suck. There are a lot of things that do suck. I'm sure you can name plenty of them. Finding out your best friend lied behind your back sucks. Getting acne sucks. Parents getting divorced totally sucks. Been there. But math doesn't have to suck. Do you like money? Most people do. Math is the language of money, and being smart in math will keep you from getting ripped off. It'll help you with planning and budgeting for
you guys like money?
vacations,
I like
and prepares you for better paying jobs. And if you ever want to start your own business, guess what keeps the doors open? Math. The best thing about math is that doing math makes you smarter and gives you that confidence that comes from feeling strong and capable, and that makes all of life better. What a lot of people don't realize is that being smart in math isn't something you're either born with or you're not. You're never stuck at one level of math.
You're never stuck at
do,
one level.
The stronger your brain gets. It's like going to the gym for your
This
brain.
is the idea behind Khan Academy. The more you do, the smarter you get.
And every time you do a math problem that you thought you couldn't do and then you figure it out, you've just shown yourself that you're stronger and more capable than you thought. And that builds confidence from the inside out. Suddenly you're like, yeah, I can do math. And anything else that people think is hard. Bring it on. That kind of inner confidence changes the way you walk into a room, gives you a better smile, and makes you feel great. You know, a lot of people think math is for other people, not men. And we've all heard the same stereotypes.
Math doesn't suck. It's a great book.
Only for guys, only for nerds with glasses and pocket protectors, or that it's only for old men who look like Einstein, or that if you're pretty, you can't be good at math. I mean, you don't need math because you're certainly never going to be a scientist. But math is for everyone. It's for you, and it'll make your life better, no matter what career you choose. So I'm going to help you out here and make math a little more pleasant. I have videos to help you out with homework and tests, and also some confidence-building, brain-strengthening math problems you can download. Some teachers might even give you extra credit if you do them, so be sure to ask. Thanks for visiting the Math Doesn't Suck channel. Practice some problems, watch my videos, and find out more about my books at danicamckellar.com. I'm really excited to share all the tricks I've learned to help you kick some serious butt in both math class and life.
So she's pretty awesome. If you can either search Danica Mckellar or you can search Math Doesn't Suck. Not Math Doesn't Exist. I don't know what dummy would think that. But so she has her Math Doesn't Suck channel, and she's got some other things. And then she goes through talking about her books. So if you're curious about her books and you want to know more about it before you check one of them out, You can also go to her webpage. If you just search Danica Mckellar, you can find her. But she's got really great stuff out there. So a reminder, just so that it's on the video for anyone that is not here today, our homework today is a combined homework. It is one assignment, and it is found in the 4.4 folder. So some of you might want to make that note that it's in the 4.4 folder. There's no assignment in the 4.5 folder at all. There's no assignment in there. So I got these notes passed out to you guys yesterday, and we filled in just a couple things. But we want to start back at the top then. So to subtract an integer, when we talk about the operation of subtraction and what subtraction really is, subtraction is addition. Division is multiplication. There's really only two operations that we deal with. Multiplication and addition. And powers is a manipulation of multiplication, like when we do exponents. But I can change any subtraction problem into an addition problem, or vice versa. I can change any addition problem into a subtraction. All I have to do is change where my signs are. So notice that this is read 5 minus 7. So if I asked you about that 7, is this 7 positive or negative right now? If I read 5 minus 7, it's positive, right? Because I have a positive 5, I'm taking away a positive 7. But notice that I have one negative or minus symbol that I can use there, and I might need to turn Smart Ink back on. A morning. So I can then take that minus symbol and say, well, instead of using it as a minus, I'm going to use it as a negative. But if I'm going to use it as a negative, I can still only have one of them. So then I have to make the operation between them addition. So I want you guys to put arrows or highlight or something, and I wish my Smart Ink would work, to the minus symbol and then to the negative. There we go. So I want you to put to the minus symbol, and actually I'm going to connect them. I'm going to say that minus then turns into that negative. The minus then gets used as a negative instead of as a minus. So just like that here in the algebraic method, that minus then gets turned into that negative. Do we have any questions on how we're taking a subtraction problem and turning it into addition of a negative? Yeah. Yeah. Yeah, well, we just started, so you're fine, buddy. So just make sure you're getting down what I have written up here. So then we started to talk briefly yesterday about minus a negative. And one thing we talked about is this symbol, or this symbol, can really be referred to as minus, right? Well, that's the first thing that we see. We think that's minus or subtraction. But it could also be referred to as negative, right? Because that's what we see here. We see that's a negative. But what's another way that we talk about a negative number? Instead of saying negative 7, we could say that value is the what of 7? Ellie? The opposite. So those really have 3 names. It can be a minus, or a negative, or an opposite. So what we see right here is actually, we can say it's minus a negative, but instead of saying minus a negative, I can replace one of those words and say the opposite of subtraction, or the opposite of a minus, or the opposite of a negative. What's the opposite of a minus, or the opposite of a negative, or the opposite of subtraction? So I'm trying to mute this if I can. I don't know if I can. We'll leave it. What would be the opposite of subtraction? Brady?
Yes.
Yeah, you guys keep moving around the classroom. You're really testing me, especially since a lot of you don't have your name tents out. That cheat sheet. Today especially, you might want to be putting stuff on the back of that name tent for your cheat sheet. Our test will be next Friday. Yeah, I normally try to put masteries. Sorry, what? Oh, I don't want to take that test yet, so give me a few more days to practice. I need more practice before I can mastery.
The opposite of
The opposite of subtraction. So guys, I want you right under here to write opposite and point to this first one. And then write of subtraction or of negative or whatever you want. And I could even say opposite of minus. What's the opposite of a minus? Caleb? Addition. So the opposite of minus equals addition. I-T-I-O-N, yeah. So the opposite of our minus equals addition. So I know we covered this really quickly at the end of class yesterday. Does anybody have questions now why, when I see two negatives right beside each other, or a minus and a negative, or a negative and a minus, or an opposite and a negative, or whatever you want to call those things, does anybody have questions how I turn that into a plus? And before I capture, I'm going to go ahead and highlight that minus negative turns into that plus. So let's analyze what's going on in these two situations down here to help us set up models. So it says write some equivalent expressions here. Anyone know the difference between an expression and an equation? Ellie? An equation has an answer, right? So this is just like a mathematical statement. It's got an operation happening. There's something going on, but it doesn't have an answer yet. So we want to go ahead and make these equations. So let's go ahead and put equals. And if I want to know like what it equals, well, let's look at where do we end. Well, I have a shift here and another shift here, and I end at -7. So my answer is going to be -7. So we know that for both of those. But notice that one is subtraction and one is addition. So now if mathematicians were not as efficient as we are, we would start every single math problem with nothing. Because you always start with nothing and then you do something. You add some or you multiply some or what. So before we multiply, we would actually have to add some in, then we could multiply. But mathematicians are efficient and we don't need to write 0 plus because it's unnecessary. So if we wanted to, we really say we start at 0 and then do what? What's the first thing that we do in this system that you see? On this number line, the first shift we take, Leah? Yeah, we go to -2. So since I could say we subtract 2, but I don't really want to use that as subtraction. So instead of saying subtract 2, if I get rid of that 0, where do we start? Sarah? Yeah, -2. Since we're not going to write that 0 out here, we actually make that 2 just a value of -2. So I agree with exactly what Leah said. We subtract 2 if we're starting at 0, but we're more efficient than that. We just go ahead and say the first actual number that we deal with. So then, I've subtracted my 2. What do I do then? Now this is where it's tricky. I then have a minus, so I have -2. I'm starting here at -2. Then I want to know what change happens to take me to -7. Olivia? So if we're going to subtract, Leah?
-7, but then you make it +.
Now wait, do I subtract 7?
Oh, 5.
I only subtract 5 because this distance right here is 5 and we're going in the negative direction. So I can either say that I subtract 5, which pushes me the negative direction, or I can drop down here to my addition problem and say -2 plus what?
-5.
-5. Thank you, Derek. Please make sure we raise our hand. But then I'm going to put this in parentheses. And now I see those addition problems, which I know how to deal with because we have those addition rules. So my advice to you is any subtraction problem you see, make it addition. Addition's easier. So my advice is even if you start with subtraction, make it addition. Now if you have a highlighter, here's what I'd like you to highlight. This minus turns into this negative. So here we use it as a minus. Here we use it as a negative. It doesn't matter how I use it. All that matters is that I've only got one still. I can't say like minus the negative because then I'd be adding a symbol. So notice negative 2 doesn't change at all. Then the only thing that changes is my minus becomes a negative. Any questions on that one? And if you don't have any questions, go ahead and try the one right beside it. You are always allowed to move on in your notes. I had some people thinking that they just had to sit there and wait. If you feel confident, you are allowed to move on. All right, now a reminder, on Monday, I'm going to have name cards to call on you guys randomly. But for now, I'm still just seeking volunteers. Who can help me with my blue change? So, of course, we quote-unquote start at 0, but we don't really notate that. Leah? Yeah, we start at 6. Technically, we really start at 0, but we don't write that because it's unnecessary. So we're at 6. Then I have a change, my red arrow change. Who can help me with both of these? Derek?
For the first column, you write 7.
Okay, so then what goes down here?
-7.
-7, because instead of using it as a minus, I change it to an addition problem and use it as a negative. And then, regardless of whether I do it as subtraction or do it as a negative, my answer becomes -1, because that's where I land. That's where I end. And again, I make my ones kind of fancy because otherwise I get confused whether it's a 1 or an L. Because in lowercase lettering, that's an L, that's a 1, they're exactly the same. So that's why I make my 1 kind of fancy. That's also why I make my 7s like that, with the little, whatever you call that. Because then once we start using Z, a 7 can look a lot like a Z that you forgot to finish. So just to tell you why I write my numbers how I do. Any questions on this one? Any other number line stuff, Sarah?
It's not a question, but
Okay.
how do you like to use this stuff on the test?
Occasionally I have open notes tests, but not everyone. So take good notes in preparation for if I say it's an open notes test, but I don't let you know until the day of the test. So if you've kind of not paid attention in class and you don't have very good notes, and then the day of the test I'm like, hey, you can use your notes, and you're like, oh crap, I should have taken better notes. So sometimes yes, other times no. Great question, I love that. Good thinking. So here we have a vertical number line, which in my opinion, anytime you want to represent a number line, I like vertical better, because if we're talking about elevation changes, we're going a positive elevation or negative elevation change. Temperature changes, positive temperature change, negative temperature change. Most things go up and down. So which of these, and it could be multiple answers, which of these would correctly represent what's going on in that number line? Take about 30 seconds to think about which of those would work. And you can think about what would the answers be, and that might help you. Alright, so if you were looking up here, you probably saw I already had written up a couple answers. But I erased them because the first thing I want to talk about is number 4 here, option 4. These are Roman numerals, by the way, which you'll learn about later in the year if you don't know about them already. V is worth 5, but the one before it subtracts 1 away from it, so that's why this is actually option 4. 2 and negative 2. I wrote myself a reminder here because it will be on your mastery assessment on what is an additive inverse. So you might want to remind yourself, a number and its opposite are additive inverses. They add up to 0. So could number 4 be, like, could that match this number line situation? No, it does not end at 0. So 4, although it shows additive inverses, is not one of my answers here. Can anyone point out any of these that do work, Ryan? Number 3, because 2 plus a negative 4 takes me down to negative 2, and it would work. Carol? Option 1, 2 minus 4 also takes me to a negative 2, and it works. What about 2 minus 2, Derek?
It won't work because 2 minus 2 is 0.
Yeah, that comes out to be 0, so that doesn't work either. Your options there that work are 1 and 3. Any questions on that? Now, these are the problems that I find very interesting because they are real math. So, I have friends that just moved out to California. I think they're crazy, but it's very nice out there. I just enjoy Ohio because we have seasons, but it gets very hot out in California. They're on the west coast. It's very bright and sunny, stays, so where's the sun rise? Anyone know how the sun moves? It rises in the east and sets in the... So, they get the sunrise later than us, but that's why time is shifted. So then they have all that nice sunshine, and it's great weather out there. But in Death Valley is out in the desert. So in Death Valley, highest recorded temperature in the U.S. happened on July 10th of 1913. It was 134 degrees. Not the heat index, not what it felt like, but the temperature was 134 degrees. So guys, it probably felt like it was like 150. Because if there was any humidity always makes it feel hotter. That was the recorded temperature. That's insane. And what's even crazier is the lowest recorded temperature was 214 degrees lower than that. Now that doesn't mean it was negative 214 degrees. That's kind of crazy. How do we figure out what that lowest recorded temperature was? How do we set up the problem to represent what that tells me? Sebastian?
I think we need to subtract it.
Yeah, because lower... Let me shift this over for a second. Lower tells me to subtract. So I can set up 134 minus 214. Now, can I actually take 214 away from 134? Well, okay, so technically, yes, I can do the math. But can it physically happen? No, not really. So that tells me that our answer is going to be a negative value, which in some situations doesn't make sense. Would a negative number make sense here?
Yes.
Are temperatures allowed to be negative?
Yes.
Yeah. Can distance be negative? No, distance, you cannot travel a negative distance. But you can have a negative temperature. This is also why I disagree with the U.S. system of measurement. How do we measure temperature? What scale? What is it? Fahrenheit. How's the rest of the world measure temperature? And what you probably use in science class? Celsius. Where's the freezing point of Celsius? Where's the freezing point of Fahrenheit? Anybody, really, just shout them out. 32, right? Freezing point of Fahrenheit's 32. Seems like a weird number. Where's the boiling point of Celsius? 100. Where's the boiling point of Fahrenheit? 212. Because if it was 112, this would have been boiling. Literally, the water would have boiled. So think about when you... So our Fahrenheit scale is extremely wonky. You know what the word wonky means? Kind of like off-kilter or whatever. So this is in Fahrenheit. If it was in Celsius, it would be a simpler problem. It would make more sense. But this is why we're going to have a very large negative number. Now, I don't really want to take 214 away from 134, because if you do this, 4 from 4 is 0, 1 from 3, 2, 2 from 1, this doesn't make sense. So, instead of doing the subtraction, what could I do to this? We just did it higher up on the paper, right?
Did you add it?
We make it addition. How do we do that? Do you know how to rewrite it? So 134, I can't change what that is.
Oh, what would it be? 134 plus.
Then I'd get like 300, so I'd get some really high temperature, Sarah. I gotta still use that minus, but I don't want to use it as a minus, so instead I use it as a negative. I've gotta keep it in the problem. I cannot get rid of it, but I can change what it's used for. Does this make sense? That I didn't change the problem, I just changed what it looks like. So that's like if I left the room, changed my shirt, and came back in. I'm still me, right? I might look different. Instead of subtracting, I might now be a negative, but it's still the same. It's representing the same thing. So now, how do I do addition with different signs? Nod a hand, okay. Oh, Ella?
Which side has more power?
Which sign has more power here? Carol?
Negative.
The negative, so I know that my answer will be negative. And then, because they're different signs, we are going to find the difference. And we do this the easy way of my big number minus my small number. And now this subtraction makes sense. 4 from 4 makes 0. I have to borrow here. I'm going to show my borrowing in red. So that becomes a 1. This becomes 11. 11 minus 3 gives me 8. Ooh, close 8. And 1 from 1 gives me 0. So I get 80, but then I have to, that's a working number, so I bring it down here with my negative, and then I label it degrees Fahrenheit, and my final answer is negative 80 degrees Fahrenheit. Guys, negative 80 degrees. The coldest temperature that you've maybe felt is like negative 10. If you remember winter like 2 or 3 years ago, we couldn't come to school because it was so cold. It wasn't the snow, it was how cold it was. It was literally too dangerous to stand at a bus stop for 5 minutes. That's how cold it is. It will freeze your skin. This temperature, you will die in a matter of hours. Like, if you do not have the right clothing on, it will literally freeze the water in your skin. So that was like in the Arctic Circle or Antarctica, or like, we will never experience temperatures that low unless you go to one of the poles. The North Pole or the South Pole. Yeah. So it would literally, like, that, it's the lowest temperature ever recorded. Well, but not recorded, right? So maybe there was nobody there to record it. So it's one of those, like, if a tree falls in the forest, doesn't make a sound. Well, if a temperature goes below negative 80, but no one's there to measure it, we don't know about it. All right, so we filled this in yesterday. Minus a negative is really, Ellie? Plus a positive. Make sure that you have that written down here. Minus a negative is plus a positive. Minus a negative is plus a positive. Now, we also converted all these to pluses yesterday. So we had negative 4 plus 3, 6 plus 1, negative 2 plus 5. Go ahead and try to solve these really quick while I write these up here to catch up with you guys. And in case you didn't show it, we showed this by making the V between them. And for any of you guys coming back from math testing, I am recording, so this video will be up on Schoology by I gotta go home to upload it. My uploader's not working here, so it'll be up by like this evening. So if you want to catch up on class, you can either copy notes from a friend, or you can watch the video like tomorrow. It'll be posted. And actually, I already have a video posted with this stuff from the Accelerated 7 math class. So negative 4 plus 3, my first problem there. Which value, since all of these are addition now, remember we're thinking about our addition tricks. Ellie? Yeah, it's negative 1 because the negative is more powerful the difference between them is 1. Now I move over here. Are they same sign or different signs? Caleb, help me out. Same sign, so we save the sign, which is positive, and then we, sum, that other S word if we want to use it. What do you get? 7. -2 plus 5. Do we have same signs or different signs? Brandon, you look bored back there. Help me out, man. Same signs or different signs? Different. So, which sign has more power? The positive. So it's unnecessary, but I put a little plus sign to remind me. You don't have to, but you can. It is correct. So then what do I get? What's the difference between them? Boom. Thank you very much, Brandon. My next one down there, 1 minus -6 became 1 plus 6. Class, what do I get when I add 1 and 6? We get 7. Same sign. Easy process. Now, -3 plus 4. We have different signs here. So we'll end up finding the difference. But I got to look at which sign has more power. So class, what do I end up getting as my answer here? Class just means anybody, really. Yeah, sometimes I don't care to call on people. I just want, like, whoever's got the answer, because I know most of you probably do. And then -5 plus 2. Again, I have different signs. I end up thinking about the difference. Ellie, what do I end up getting? -3. The negative is more powerful. The difference between them is 3. Please, if you have any questions on this, ask me. Any questions on these 6 problems that we solved? Anytime you see a minus right up against a negative, parentheses don't count, shove them together, make it addition. I handed them out late in class yesterday. Should hopefully. And then guys, I will have the PDF of your finished notes. That'll be uploaded like before you leave school. So there will be a PDF, like a file, that you can access that has like everything that's been on the TV will be on that PDF. So here, it just takes us into 4-5, which is dealing with the rational values. And again, rational means any number that can be written. What does rational mean, Ella? As a ratio or a fraction. So notice we're now working with fractions. The absolute same rules apply, but what do I have to be careful while working with a fraction or multiple fractions? When I'm adding or subtracting fractions, I got to be very careful. Could I, and there are problems like this on your homework, could I Can I do this? 1/2 plus 2/8, Olivia? Yeah, I need to make and it's actually least common denominator because greatest, there's a lot of numbers that 8 and 2 could have in common, like 800 could work. But I want the least common denominator, but what you might be thinking of is finding the greatest common factor. So, but that's in reducing. When we reduce fractions, we look for greatest common factor. When we are looking to add or subtract, least common denominator, it's weird vocab to remember. It gets easier as you go. So Brady, what would I have to do here to be able to add these?
You can multiply them by 4.
Them? What is them?
We'll multiply the numerator and the denominator by 4.
Okay, so right here.
The teacher last year did this.
You gotta be specific. Why are we doing what you're telling me to do?
Okay, you gotta do the 1/2 on the left side. You have to multiply that by 4. Multiply the number on top by 4. The answer is 4/8.
So now how do I add the fractions?
So you don't change the denominators?
Denominator stays what it is. You have to start the same, and it stays the same. So if you don't start the same, your first step is matching your denominators, whatever you have to do. I can do anything I want to a fraction, as long as I do it on the top and the bottom. So multiplying or dividing, I can do whatever I want to a fraction, as long as I do it on top and bottom. So I multiply the top and bottom. Now I have 4/8 plus 2/8. That would give me 8. 4 plus 2 on top, 6. I could then reduce this.
Okay, so you would divide 6/8 by 2, and it would be 3. It would be 3 for 6 and 4. Yeah, 4
Yep.
for.
Absolutely correct. So just to review that addition of fractions, always first check for common denominators. If not, make it happen. Then add the numerators, keep your denominator. So when we deal with doing that with positive and negatives, all we have to do is remember our fraction rules and apply our addition or our subtraction or whatever rules that specific problem calls for. So these are just examples that you can look at to help you remember. Let's look at this. Got it. -1/5 minus a -1/5. The first step I need to do here to make this easier. Remember, the goal of this class is to make your life easier. Looking for somebody aside from Brady, because otherwise I'm going to have to start paying him.
No, pay me.
I'll have to double your wages.
Come on. Let's do it.
Leah?
You have to multiply 1/2 by 2.
Wait, where are you? I'm looking at this. Got it. Oh, you're down here. Hang that, keep that thought. You're right. Keep that thought. So, in the got it, Brady.
You have to see if the symbols are the same or different.
Not yet, because that we do when we have an addition problem. I don't have an addition problem. You're thinking of an addition rule. I do not yet have an addition problem. Brandon? Make it, and how am I allowed to make this an addition problem? Yeah, minus a negative. Guys, show this work. You take both the minus and the negative to make a plus. Now, -1/5, the first -1/5, that still has its negative because I didn't use that. I can't use that. But I used both of those. So now I have -1/5 plus 1/5. How do -1/5 and 1/5 relate to each other, Carol? They're additive inverses, which we know then will sum to 0. Questions on this? How we were allowed to make minus a negative into addition. Guys, use your notes as you're doing your homework. That's the best advice I can give you. Use your notes while you're doing your homework. Most of the problems in your homework, like I made your homework. I don't write every problem, but I write some of them. I make your homework based off what's in the notes and what do we need to practice. So, Leah, back here, and I'm going to zoom in a bunch so I have some space. So this is model each subtraction expression on the number line. So I agree with what you were about to start saying. If I didn't have a number line, I definitely have to multiply these things. I might be able to sneak away without doing it here, but I like what you were about to do. So say again what you said the first step for this should be.
Turn 1/2 into 3/6.
Turn 1/2 into 3/6. How? How did you tell me I need to do that? By multiplying by 3. Because I see here that my denominators don't match, I first have to make them match, and I can turn 2 into a 6 by multiplying by 3. So show that we multiply by 3 on top and bottom. And this is also why we use the dot for multiplication. It's a lot easier to write. So now what we really have is negative 3/6 minus 5/6. Now we're going to find the answer to that in a second. But when I look at this number line, one thing that I need to know is what's the value of these marks? Like those marks on there have to mean something. How do I know what each of these marks is worth? How do I figure that out? How do I figure out what my tick marks? That's called a tick mark, not like a deer tick. I don't know exactly why. Brady, do you know?
I'm just gonna guess so that next to the 3. That way.
Next, sorry, this is a question mark.
Oh. Okay.
I'm trying to figure out what each of these is worth.
So, would it be...
Yeah, but we can't just say, since this has a 6, they're worth 6. That doesn't always happen. So we have to be able to check how, I mean, you're right in this problem, but we have to be able to figure that out on our own. Caleb? So you said after that, this is 1/2? That's not half of the way to 1. Here's what we do. We're running out of time, so hang on to it. Here's what we do. You've got a few marks between 0 and 1, right? And I want you guys to write this word. This tick mark is your first tick mark. This is your second, your third, your fourth, your fifth, and 1 is your 6th tick mark, which means that 1 is actually 6 out of 6 to make 1. So that tells me that the denominator, or what each of these tick marks is worth, is a 6. So this would be 1/6, or 2/6, or 3/6. That tells me my denominator. We're going to do the same on the next number line because they're not the same value on the next number line. So if I need to show -3/6, I'm going to highlight this in green and show that with my green pen. I would start at 0 and go -3/6. I go 1 and 2 and -3/6. So here I'm at -3/6. Then I'm just going to use red. If I subtract a positive, now this is where people get kind of goofed up. If I subtract the positive, I could also rewrite this as addition of a negative, right? Instead of subtracting a positive, I could make it addition of a negative. Now, if I added a negative, what direction would it tell me to go? Leah? Yeah, down, or in the negative direction. So I'm going to go 5 more 6ths. 1, and 2, and 3, and 4, and 5. I land right here. I passed -1, so I'm at -1 and 2/6. So my answer up here becomes -1 and 2/6. Now I can actually simplify that fraction. Since 2 and 6 share a factor, they can both be divided by 2. I divide them both by 2, divide by 2, and divide by 2, to reduce that to -1 and 1/3. So that ends up being my final answer. Reduced down is -1 and 1/3. Any questions? All right, let's move on to this next one. So we again need to figure out what the tick marks are worth. So start counting. There's 1 tick mark, 2 tick marks, 3 tick marks. 4 gets me to 1. So that means that 1 is actually 4/4, and my denominator for these tick marks, they are worth 4ths. Any questions on how we figure out what they are worth? So this is now 1/4. That's 2/4, 3/4, and 4/4. So we start at -2 and 1/4. So I can go ahead and show that. I'm going to solve this just using the number line method. So to go to -2 and 1/4, -2 and 1/4, here I start. Then I have minus a -3 1/2. Minus a -3 1/2. What can I do to that? Again, making my life easier. What makes things easier? It's the last thing we're going to do today. Minus a negative. Refer to the front of your paper if you can't remember. Minus a negative is really... Carol? Except I called on Carol and somehow you threw your voice across the room. This really can combine into addition. So if that becomes addition, what I have is negative 2 1/4 plus 3 1/2. So to show the plus 3 1/2, I go from here. Well, if I move a fourth, that's 1/4. Now I can move 3, 1, 2, 3, and I still have 1/4 left over. I land right here at a positive 1 1/4. And that is everything we have time for today. Please make sure that you have everything that we talked about today. The PDF will be on Schoology, hopefully by the time you guys get to AO. So thank you very much. Try to get that homework done if you can, but again, it's not due until Tuesday because it's assigned on a Friday. 4-4-4-5 practice. It's always up on the homework board. It's one combined assignment. It's in the 4-4 folder.